I'm Ishwar, software consulting engineer with Customer Experience Group from India. The objective for today's session is to kind of give you an idea how auto healing can be achieved just with NSO and open source monitoring tools. We'll kind of get into a typical service delivery environment, how does it look like, and then we'll go to the solution components, and followed by a demo, and we'll also take a look at how things should be standardized in such a way that we kind of get the best outcome of the auto healing. And we'll also talk about successful automation journey approach that we should be following. Taking a typical service delivery environment, maybe you can take an example of infotainment service. So infotainment service in turn will have a lot of hardware-related kind of servers or networking or even the software-related layers like middleware, app layer, and database layer. And in order to kind of support that, we also have other layers such as BSS tool stack, and we also have analytics tool stack. All of them work together in order to provide a service to the end customers. And all of these are stitched together by the network so that the customers can consume the service. It could be any kind of infotainment service that you are using it today. So let's take a scenario where one of the interface goes down, wherein the complete infotainment service, which is kind of loaded on a server, which is attached to a top of rack, maybe that interface goes down. Now, what happens next is that immediately the customers will start facing issues. They'll not be able to kind of consume it. They'll raise escalations, and there'll be n number of tickets that are coming to the support desk, and then we have to immediately react to it, right? And once that happens, there'll be a lot of teams. So each layer definitely will have their own operations team, application layer operations team, and middleware database, and all of the teams come together. And how many of you are from operations background? Just a question. Okay, good. I think you would be able to relate to the next slide. What happens next is that, right? Because if you're into the operations at some point in your career, you would have experienced that. Because if there are different teams which are managing different parts of the same service, then definitely they would say that it's not me, it's you, right? So, and if it's not getting resolved within certain limit, maybe a service level agreement, then there'll be a crisis manager who is coming into the picture and kind of hitting all of them. And then this is what happens, right? Then all of them work together to kind of make sure that the issue is sorted out and then take it further. So jokes apart, so we'll take a high-level look at what is the problem resolution flow. Initially, they start with kind of what is the issue and who is reporting the issue and all that. The second step that they generally do is like identify the issue category. So issue is something, is it related to maybe CPU, or if it is network, then maybe it's bandwidth, or is it access list, right? So likewise, for each of the domain, there are different categories. For example, storage, you have the issue could be because of a disk, or issue could be because of a LAN. So this is kind of going more in detail about the KPIs. I think some of my colleagues touched upon yesterday. So this is kind of detailed information. We're getting into that. So they identify where exactly issues coming from, right? So, and after that, they identify the issue type. So the issue type could be, for example, if CPU is the category, and the issue could be like high consumption of the CPU itself. And if it's something related to maybe network bandwidth, maybe the bandwidth is completely exhausted, and because of which they were not able to kind of consume at a normal optimal level. Or maybe there is a congestion because of which the QoS kind of got lower. Maybe something similar example for a LAN, it could become offline because of which the entire stack came down, right? So first they identify the category, the next they identify what is the issue type, right? And once they identify that, they know where exactly the issue is coming from, and what is the kind of issue, and they go back and look at all the KB articles that are already out there, maybe a SOP or you call it as method of operating procedure, or maybe you talk to the team who is already kind of who resolved that issue. Maybe that kind of solution is already in someone's mind, right? You talk to the team, you find the solution, and you go ahead and apply that, right? So once you apply that, you verify that the problem is resolved and then you're able to kind of get the service back up online. Once it is solved, so we also verify with the customers whether they're able to consume the service as early as it was before, and then we kind of close the case. So this is a very high-level flow, but we are trying to see how NSO can be used to automate end-to-end from the beginning till the end, from the identification of the problem to kind of solving it automatically. So before getting into the actual solution, so problems can be classified into two types, right? The problems that are known and problems that are unknown, right? So within known problems, it can have known solution. We have seen that problem earlier, and we already know the solution for that. And there are problems which we faced it, but we haven't got any solution today, till today, right? So we are still working with the vendors or BUs to understand what exactly it is. We are still doing our root cause analysis and all of them, right? So the unknown problem is something that hasn't occurred yet. So we don't have the solutions for that also. So the potential candidate for doing the auto healing is this part, right? The problems which are known and which is having a known solution, right? So these are the candidates which can be automated without having a human intervention. For this today's solution, we are using Network Service Orchestrator. All of you know about it, and we have we have created a package which has a couple of lookup data. We'll go through it a bit later, and we have Nagios. I hope you are aware of this. It's an old-time monitoring tool which is used for monitoring different infrastructure elements. So we are using it for today's demo. And it also acts as an event handler. So whenever there is a event that is detected, for example, a particular LAN goes down, it also takes care of notifying to the external system. Here in our case, which is the NSO. So Nagios is going to notify back to NSO that there is something wrong, and then NSO in turn will take an action to solve it. And we have a Nexus device. So that's kind of a demo device for today, but it's not it's not just Nexus device. It can be any device. It can be any infra elements, right? As long as it is kind of monitorable, and then we are able to kind of apply some fix via configuration management tools like NSO. So this is the solution architecture. We have Nagios monitoring a Nexus device. So monitoring a Nexus device, an interface goes down, so it keeps checking. It gets to know that there is a interface down, and then it immediately performs 2 more checks. Again, this is a basic feature of Nagios to do some basic correlation so that it's not giving false alarms. So it performs the checks for 2 more times. Basically, it performs for 3 times, and then it's going to let NSO know that, hey, for this device, this particular interface is down, right? NSO, once it receives it, so it will try to identify what is the issue category. Is it something related to interface, or is it something related to bandwidth, or it's something related to some other infra elements, right? So in our case, it's an Nexus device and it's an interface. So it will go and identify its interface, and then the state is down, right? So it uses that to figure out what is the kind of solution that it can go ahead and apply back to the device so that the interface will come back up online. So it searches internally, and then it says that I see a solution, let me apply. And you can see that it gets sorted out. So once the interface is back up online, the Nagios monitoring tool is something which is kind of observability tool, which keeps monitoring that particular interface, and then it'll get to know that the interface which was down some time ago, it's back online. So it'll again notify NSO saying that, hey, this particular interface is back up. Now NSO will already know that it has applied some fix for that particular interface now, and it is working. Now it'll go and update it audit log that this particular fix is actually working. So it'll be available in the event history. Now we'll get on to the demo. So on the left, I think left to you, you have the Nexus 9K terminal. On the right is the WebEx collaboration platform. So with the Nexus, the demo is something very simple for today just to understand, to make you understand. So we are going to shut down an interface and see how this package that we created can actually identify that and bring it back up online automatically. It'll play? It's playing, okay. No. Yeah, I think it should play now. So it's a recorded demo just to avoid kind of connectivity issues. So we have it recorded so that it's easy to kind of save some time. Okay, so this is the Nexus 9K terminal. And on the right side, we have a WebEx collaboration platform. The automation that we are doing is completely kind of in the background. It's not visible what's happening. So we thought of kind of giving an interface so that like you get to know what exactly is happening in the backend. So we have created a WebEx bot that will let us know what exactly is happening. What's happening in the background. So this particular tool is the Nagios tool. We are monitoring the Nexus 9K device here, and we are monitoring Ethernet 1/1 and 1/2. Right now, the state seems to be okay. And you can also look at, we are using like SNMP protocol to monitor that. And the next screen is about the NSO. We have created a sample draft package which talks about the auto healing. It has two components to it, which is lookup data and actions. So lookup data is the one which has all the brain of it, and actions are the one which is used for capturing all the events, processing it, and also kind of applying the fix back to the respective devices or infra elements. So the next one is the lookup data. Within lookup data, we have some constructs to make sure that it works properly. The first one is the entry criteria, so which is kind of a group wherein you can specify what all devices can participate into this auto healing. So we do not want every devices in the network to be participating into this, because we may develop something and then later release into the production. So we can ensure that only devices which are part of that group kind of gets into this auto healing queue. And next one is the KB classifier. This is the one which is used for identifying what is the kind of issue category. We talked about issue category, if you remember, interfaces, network, CPU, and all of them. So we have added a sample category called as interface, and that has some keywords attached to it. So these are the keywords which are used to determine what kind of event is coming from. So Nagios is going to send an alert back to NSO, but how does NSO know what kind of category it is? So we use this kind of, this is again a simple one. We can make it complex and make it more kind of customized as per the needs. So we look at, we actually kind of query these keywords and identify what is the issue category. So it identifies, in our demo, it identifies that interface category. And the next one is the KB definitions. So we talked about issue category, and we also talked about issue type, right? So category is interface, and issue type is something like, is it down or up? In case of CPU, is it like high or low, right? Likewise, each and every category has its own type of issues, right? So means issue types. So this KB definition is the core part wherein we are defining what is the interface and what is the category, what is the state, and what is the solution that we have to apply. Right? So in this case, the KB type is interface and KB state is down. And if that is the case, then go ahead and apply this particular template. So this template is kind of reusable. It's not just template. We can also go ahead and execute sequence of steps, operational commands as well. So for the sake of demo, we have kind of taken a configuration which is reusable, which can be applied for different devices and different interfaces also. It's a reusable kind of a template. The last one is the event history. This is where all the events will get recorded, whatever it is, even if the auto healing solution is able to solve it or not solve it. I mean, it's not unable to solve it, it'll get locked here so that the team can come and look into this and then later solve it. In case if it's not able to solve it, at least we have a track of what's not solved automatically. They can go and look at and automatically solve it. So this is also an important part, because I think this we'll touch upon a bit later as well. There has to be a proper handoff between automatic solving and also to the actual SMEs who can actually take it from end to end. So now getting back to the demo, in your Nexus console, like I can just show the interface brief so that all the interfaces are displayed here. You can look at what is the current interface state. Ethernet 1/1 and 1/2, they are up. And I'm also going to the Nagios, so you can look at the services status. They are up there as well. What I'm going to do is go shut down a particular interface, and see how the NSO can automatically bring it back up online. So this is a simple example. I want to repeat it, but just to make you kind of give you an idea how this can be achieved, right? So we're shutting down, and I'm doing a show interface brief again. So now Ethernet 1/1 is administratively down. So it's down now. If you go back to the Nagios, it should be down in a few seconds. Again, it depends on the configuration that we do on monitoring tools, how frequently it has to go and check it. I think it will take about 5 seconds or 10 seconds. So now you can see that it has become critical, but the attempt is 1/3. What it means is that it first checked, and then it got to know that there is a problem. Now it's going to make 2 more attempts to make sure that the problem still exists, and only then it will notify NSO. So now it has notified NSO, and you can see that the bot is saying that I see that interface Ethernet 1/1 on the device Nexus 9K is down. Let me see what I can do. So basically, it has got the Nagios has sent out a message to NSO, and NSO in turn is actually kind of giving all these messages via WebEx bot. Now it says that it found a solution in knowledge base. So basically, it figured out what is the kind of intro element. Okay, it's a network device. Now the category is interface, and the issue type is down. So it figured out that there is a template that it can go ahead and apply. So now it is saying that I found a solution in my knowledge base. So let me try to apply that. So once it is applied, the device takes some time for it to reflect the interface status, so that Nagios will get to know that it is up to date. And once it is back up, it's going to notify back to NSO that this particular interface is already up. And then NSO will get to know that that particular problem, or I would say the solution that it applied, it actually solved that particular problem. And if you look at here in the Nexus, in Agios also the service is backup. If you look back in the Nexus also, I've executed show interface brief. Again, the interface is online back again. So this is a kind of a example to make you understand how we can actually kind of just use NSO and open source monitoring tools to do the auto healing. Definitely, I think a lot of colleagues from I think the other region, they've covered about Crosswalk network controller, which is more kind of versatile, and it has everything, and it makes a lot of things easier. So, but this is just a basic thing that we can at least kickstart, understand. As a developer, I think we want to understand what exactly it is, so that it's easy for us to take it forward. Now, in order to have a kind of a proper self-healing solution, I think these are some of the important pillars that I could think of. Definitely, in case if there are anything that you think that you can add, please do let me know in the feedback form that I'm going to share it to you. The first one is the strong knowledge base. So right, we need to have a knowledge base kind of getting accumulated. Maybe we can start with manual build. So manually we have to go and add the event handlers. We'll have to go and create the actual solutions in the NSO, right, in the KB classifier. And then, because this is again a issue by issue, we'll have to look at it. What could be the problem? What could be the solution? We'll have to build that manually. But this is kind of time consuming. So we can also consider an approach to automatically build this kind of using machine learning. So to figure out the problem areas and figure out also the problem, applicable actions that can solve the issues. Right? And then we should also kind of concentrate on building machine understandable fixes. So most of the digitized assets that we have today, the digitized KBs that we have today, it's again a kind of a document which we kind of follow step 1, 2, 3, 4, and then manual intervention required to kind of go and read that out and then follow it and then fix it. Right? So we have to convert that into a form which is understandable by machine, so that everybody can kind of go out and execute it. So to have a proper effective, I would say a correlation or a situation analysis, I think we need to have a fully mapped CMDB. It's not CDB. CMDB is configuration management database. It is the one which is used for mapping the relationship between different infra elements, not just infra elements, also between software elements that are into the picture. So if you're not keeping that up to date, it is very difficult to identify what exactly is the issue and what is the dependency that it is actually kind of affecting it. So the technologies keep changing, the stack keeps changing. So this has to be kept up to date in order to have a proper auto heal solution. Because we saw a simple example today, but there could be kind of a bigger issue in which we have to understand what all other dependencies that we have. So CMDB plays a major role in having an effective correlation. The next one is the technology and process. So we need to have a proper technological stack. So for example, configuration management, NSO is a best-in-class configuration management that we have, not just for networks. I think we can also do it for other infra elements also, like servers and other, which be it virtual or cloud as well. We need to have a proper monitoring and correlation service. So with the example that we saw today, it is very simple, but that correlation may not suit all the needs, right? So we need to have a proper stack there. Maybe I think Crossworks that they showcased yesterday is one of the tools which is already available in helping in figuring out all the KPIs to be defined easily, like a drag and drop, right? So we don't have to spend a lot of time. But with this existing setup that we are demoing, so we have to do a lot of work. And then the next one is the process standardization. I think you would have come across this particular issue that whenever you're trying to automate something, you kind of develop a service package or an action package, but at the end of the day, the configs are not in the standard format so that your service fails, right? So standardization is a big problem in automation. So we have to make sure that standardization happens across everywhere in the operations that we follow, in the naming convention that we use for the devices, in the technology or every action that we are performing. We have to make sure that it is standardized so that the automation will go through smoothly. And we also need to have an effective handover. I think I talked about it. So not everything can be solved by means like automatically, right? So there could be some issues that the solution may not be able to solve it, right? So in that case, we have to have a kind of a process in place so that it can actually hand it over to the SMEs, and then they can take it forward from there. Probably it can attach all the relevant logs so that they can look at it. So what all solutions it has tried, and then it can give it to the person, and then they can actually take it. So by this way, we are making sure all the issues are being handled, and also automating a few of the issues or critical issues for which we have known solutions. Coming to the benefits, obviously the human intervention can be reduced. And the mean time to repair the problem can be reduced to a great extent, and then improved customer satisfaction, again, which is an indirect benefit, right? Some of the use cases here are just for your understanding, but essentially any problem or any service which doesn't require human intervention, and we know a solution or we know a fix, so we can actually go ahead and automate it. So these are some just for your understanding. Maybe on-demand a link addition to an Ether channel, that's one use case. And I think yesterday for the introductory session from Kuhn and Soumya, they were talking about sustainability. So if you're able to identify the interfaces which are actually powered on, but it's not being used, then we can actually put a mechanism in place that it can automatically go and shut it down. So that could be a better use case here as well. So imagination and also the problems that we are foreseeing is the one which we have to kind of combine together and then kind of think about, or wear an automation hat to kind of go ahead and fix it automatically. And then some of the use cases like a dynamic route addition, automatically switching between different routes, restarting a services based on a certain conditions if it is meeting, and performing some automatic checks. So some use cases, but we can extend back to anything that we are actually looking in, that we are actually getting in our environments. Kind of an approach that I put together just to kind of give some best practices that we have seen through till this decade, for complete decade. So automation is kind of a buzzword. So everybody talks about automation. We want to automate everything. But is it really kind of making it worthwhile, or is it giving real benefits back to us by automating a particular thing? Because that's something that many of customers who want to kind of start the automation journey fail on, right? So because we immediately jump in and we pick things which are visible to us, and then we go start automating, but we are really not worrying about is it really worth automating it. So the first thing is that you have to do an assessment in case of, at least for an auto healing, but it's applicable for other automations as well, meaning automation of the services, creating service packages as well. So look at the past history of that particular problem, how many times it has occurred, and is it really making some impact? So did it kind of bring any downtime, or it costs any kind of SLA kind of penalties, right? So you have to look at that and then understand, is it really kind of making impact? And you can also use the other factors like criticality and severity. I'm talking about the ITIL terms. You can also use the criticality and severity to figure out what are the problems that you have to go and kind of sort it out. So the next thing is, after the assessment is done, you are done with, you figured out what all the issues that you want to kind of start automating it. The next one is important thing is the ROI analysis. The ROI analysis is the return on investment. So it's not just the money part. It can also be kind of the other intangible benefits that we are going to get it. So we have to make sure that the first thing that we have to do is like how much effort is required to automate that. And after automating it, how much time that it is going to save for us, or be it the other factors like intangible benefits as well, how much it's going to save for us. And then sort it by the max returns that we are going to get it. So out of all the use cases or all the problems that you've seen, or all the surveys that you've seen. And then kind of pick the top priority items, the problems or the services, and then apply the business priority. Like for example, every company has its own business priority. So Cisco has sustainability as one of the top priority for Cisco. So any kind of use case which is kind of helping or kind of getting into sustainability circle, I think we'll take it up. So something like that, I think we'll have to apply the business priority to pick up the use cases. And then we get into the framework, right? So I'm just talking about the customers who want to kind of get into the automation journey. But I think most of you are already into the automation journey. But like to start with, I think we'll have to have a proper framework in place so that that is something which is scalable. For example, we need to have NSO, which is a very good platform for managing the configurations. And likewise, we also need to pick and choose the right set of tools in place, the orchestration tools and all the tools which are required, and then make sure that it is scalable. And also, it is supporting the future enhancements. So that is very much important, because if you're not designing properly from that state, it is going to kind of backfire at a later stage. So next process, the automate. So after picking up the top use cases, we kind of align the team and then start the automation process. The important thing that one important thing I think most of us, even us, like miss is that we define a target so that that this particular use case we are going to automate within probably 3 months. But what we fail to do is we don't go back and really look at, is it done within 3 months? Have we invested only 3 months? But if you're not doing it, if you're not tracking and measuring target versus actual, so it may result in the negative ROI. Because at the end of the day, we want to make sure that we want to reap some benefits out of it, be it a dollar value or be it maybe intangible benefits. We want to reap out of it. So if you're going out of the given timeline, I think it's going to kind of give a negative consequences later. And the last one is after automation is done, we'll have to make sure that we make a continuous improvement, because continuous improvement is something very much essential today in this decade. The services are getting changed fastly, technologies are getting changed fastly, tools are changing fastly, so everything is getting replaced. So it has to be dynamic in such a way that all the automations that we have done, we have to make sure that it is kind of up to date, and then we make continuous improvements so that it is still able to reap the benefits for us. So most of the cases, if the technology changes, we kind of don't go and look back what all automations we have done. It kind of it's in the bookshelf only. So we have to do a continuous improvement and take the next use case and repeat the cycle again. So this is just to give a brief on like what all things that you can consider to start your automation journey. If you have any questions or you want to know more, you can drop an email. This is my email address. And in case you have got some feedback, you can pick your mobile and then you can scan it and then provide your feedback. I'm up for the questions. Thank you.